After some in-depth research from scientific journals, recorded lectures, and Wikipedia, it is clear that antimatter has behavioral differences over matter, giving probable chances that its production in the universe differs as well. If this made no sense to you, here's the breakdown. Try to keep up. Antimatter and matter are made up of subatomic particles. Unlike matter, antimatter is made up of antiparticles. We know we have protons, neutrons, 6 quarks, and 6 leptons. And our observations find antiparticles to have all the same properties as our known particles with opposite charges. For example, antiprotons are essentially negatively charged protons with everything else the same. And positrons are the positively charged electrons, which exist in certain energies around the nucleus. Or in this case, antinucleus. Makes sense, right? Because the super cool part is, when they both contact each other, they annihilate completely at an unbelievable efficiency. Now before I continue, I want to explain why their efficiency is so insane. We first have to discuss E equals to mc squared, founded by our good friend Einstein. This equation describes the amount of energy stored in any mass. Using this equation E equals to mc squared, we can find that the amount of energy produced from 1 kilogram of matter is about 90 petajoules. The efficiency rating of 1 kilogram of coal, the way we extract it, is around 8 kilowatt hours or 28,000 kilojoules. That makes coal around 3.2 to the power of negative 8% efficient. Now let us look at uranium-235. It is estimated to produce 24 million kilowatt hours of energy with just 1 kilogram using nuclear fission. This is great, but it really only makes uranium 0.1% efficient. Now back to antimatter annihilation. This process is insane, having an efficiency percent of 100. In perspective, a kilogram would release almost as much energy as the largest thermonuclear bomb ever detonated. The energy released from this explosion would be 6,000 times greater than what was dropped on Hiroshima. It is why antimatter is seen by many to be a form of weaponry. These numbers may be worrying. However, Symmetry magazine states that humans have created less than 20 nanograms of antimatter to date, and human capabilities are limited to only a few antiatoms. In perspective, that is not even enough to interact with light, so physicists are only able to estimate and predict what antimatter would look like. If all the human-made antimatter were annihilated all at once, they would produce only a bit under 3,500 kilojoules. In reference, ck12.org says it takes 2,257 kilojoules to boil up a kilogram of water. This makes the possibility of an antimatter extinction bomb very unlikely. Now let's dive into the mind-numbing part of antimatter, where scientists have some idea what is happening and form disagreements. For this, we must go off topic again into gamma ray and matter interaction. It's as straightforward as it sounds. When photons are at the end of the electromagnetic spectrum and have the shortest wavelength at around 100 atometers, they are gamma rays. During an interaction with matter, gamma rays can ionize the atoms of the matter in 3 different ways, in order of least to most photon energy requirements. Gamma rays can either experience the photoelectric effect, Compton scattering, or pair production. As of right now, we have no concern with the first 2 effects, but I encourage viewers to research them either way. Pair production requires a photon with the highest quantity of energy, at least 1 megaelectronvolt, to do something really cool. When the photon is near nucleus, the photon disappears and leaves behind an electron and positron. The kinetic energy of the pair is equal to the photon energy. Eventually, the pair loses their kinetic energy and then collide, ending each other in beautiful annihilation. I know this is a lot to take in, and I would like to thank Google and Wikipedia for it all. And you may be wondering, what does this mean? Our observations show that a pair is formed, describing each particle must have a corresponding antiparticle. If the problem of this implication has yet to reach you, let me break it up and explain the question of this video. This observation and our understanding of symmetry describes the identical amounts of matter and antimatter should have been formed by the Big Bang. However, our non-annihilation existence indicates an imbalance of matter and antimatter. This is baryon asymmetry, and it is one of the biggest problems in physics without a current solution. Today, you will be bathed with the knowledge, theories, and hypotheses that I have researched about baryon asymmetry, as well as my opinions and the hypotheses I believe answered this question. These are my opinions after I conducted my own research. The Giga geniuses who understand this fully are working to find the objective truth behind it all. So without further ado, let's explore the mind-boggling physics of baryon asymmetry. I think there are generally two types of theories that look at this. Let's split them into groups. Group 1 hypotheses conclude that there's the same amount of antimatter and matter produced from the Big Bang and exists with us today. The missing antimatter can exist in deep space or in exclusive antimatter galaxies, unable to interact with baryonic galaxies. Group 2 theories, however, have no issue in going absolute batshit crazy without warning. Group 2 theories agree that the Big Bang should have created the same amount of matter and antimatter, while exploring why it failed to do so. The Group 2 theories and hypotheses are the one that break our understanding of symmetry and order in the universe. My first opinion is that if Group 2 theories can be proven, they will lead us to understand the creation of our universe through different lenses in a way that we never have done before. And in turn, my second opinion is that Group 2 is considerably more awesome than Group 1. We're going to start off with Group 1 because they are conceptually the easiest to handle and make sense of. The first theory in Group 1 states that the universe is a heterogeneous mixture of matter and antimatter. Both types can be found to dominate different regions of space. As to our knowledge, antimatter interacts with light the same way matter does and would look exactly the same. Galaxies we see in the night sky can potentially be made up of antimatter, while we are protected by the emptiness of space in between us. The problem I have with this theory is that it still leads to antimatter annihilation. You see, empty space is not completely barren. The most remote parts of the universe between galaxies have at least 1 atom per cubic meter. This density can still allow for antimatter annihilation by contact. In my opinion, this is enough to start an explosive chain reaction in space to destroy much more. With the vastness of space as a heterogeneous mixture, I think such a chain reaction should have already begun, killing us all. We could find how far away these regions could be by examining the gamma radiation brightness given off by the annihilations. However, we still have not detected any zones where this happens, leaving us with only estimates of where they can be. This type of theory currently seems very unlikely in my eyes due to these reasons. If any antimatter regions in space do exist, it would have to be beyond the observable universe and stay away from matter in ways we have yet to learn about. The next step to this theory would be the antimatter mirror universe. This universe would have time traveling towards the Big Bang. Essentially, the products of the Big Bang could be considered as a universe-anti-universe pair. Now, this part is going to be hideously oversimplified, and I yet again highly encourage viewers to research any terms I mention and to continue learning. Charge parity and time symmetry state that all physical processes remain the same if we replace matter with antimatter, invert space somehow, and reverse the flow of time. The Big Bang works well as a model for pair production because the implication of CPT symmetry is that an anti-universe pair must exist. We do not have any proper evidence of CPT violations. However, CP symmetry has not always been followed by our findings by observing subatomic particles. The existence of the anti-universe goes all on the assumption that CPT symmetry is obeyed everywhere, which is not a poor assumption, but it still is an assumption. I'm not stating that CPT symmetry has been broken. If I was, I would have an angry group of physicists at my doorstep with baseball bats. I just think that there may be other and better explanations for the baryon asymmetry. The anti-universe theory is supported by many in the scientific community. I think it is probable that the anti-universe could be the explanation for the observed baryonic asymmetry. But I think there may be a better explanation. With that in mind, what about we get much weirder? Welcome to Group 2 theories, where nothing has to make sense to the ordinary observer. We're going to discuss baryogenesis. This is the something thought to have happened during the start of the universe to give us more baryonic matter than anti-baryonic matter. We have to thank this process because if it didn't happen, well, neither would any of us have. This process is the real MVP, and we have a lot of questions and not many answers. The reasoning behind this phenomenon can be seen in two different ways. First, either the universe just likes matter more for some reason, or second, the universe created equal amounts of each and slowly something had created an imbalance over time. You can pick your favorite because there's no data to prove one of these is superior to the other. Personally, I find that imbalance over time makes the most logical sense. It fits our original theory of matter and antimatter created equally, and there's no initial baryonic asymmetry. But it also allows us to go to the further conclusion that we don't know as much about antimatter and matter as we think we do. If these conditions are met, a logical hypothesis can state that antimatter and matter differ by not only their charge. One beautiful thing about failure is that through elimination, we can get closer to success. And I can assure you, with how wrong we were, we got so much closer to success. Let's get back to some physics. Neutrino oscillation is a phenomenon that bends my mind and a bit of the standard model. The main spice of it is that neutrinos oscillate between three flavors: the electron neutrino, the muon neutrino, and the tau neutrino. Essentially, physicists get really excited about this as it can lead us to different theories as well as many intriguing experiments. The reason why I brought this up was not to mess with our already limited knowledge of particle physics, instead to mention the new discoveries made from neutrino oscillations that can potentially solve the baryon asymmetry issue. You see, Japan, a very non-Western country by the way, had a recent research breakthrough by the T2K experimental scientists. Using the Japan Proton Accelerator Research Complex in Tokai, they sent a beam of neutrinos 295 kilometers away to a detector in the city of Hida. Their observations found behavioral differences between neutrinos and antineutrinos, being as different as they can get. These revolutionary measurements have brought a huge contribution to the explanation of baryonic asymmetry. The data shows that neutrinos seem to have a much higher probability of oscillating than antineutrinos, challenging the way we look at antimatter. This is the first step to finding definite proof of CP violation in our universe, but overall shows us that antimatter acts differently than matter. My take is that this experiment has shown us we actually know very little about antimatter and its properties, and given this, I truly believe in the hypothesis that antimatter can be produced by the universe in lower quantities or at different rates. Until we can get better and more efficient at creating and studying antiparticles, I believe the most probable reasoning behind baryonic asymmetry has to do with the difference in antimatter production.